when it moves to the second half of the 20th century, a huge boom in the optimization field, especially many of the common terms and methods we are using today started to emerge. So a first start is by Danzig in the 1950s, 70s, the linear programming with inequality constraints. If you remember previously, it's mainly the equations as constraints. But now when we add more inequalities, it becomes commonly used optimizations by today. And then it's more of the solving strategies, like some of the interior point method. We will briefly talk about when we start to introduce linear programming in the second half of this class. The linear term is a special, very important concept and method when we solve optimization or general computing methods. You may think when you compare linear and non-linear, you may think linear is simple, right? So which one is more challenging to solve? You may think linear or just a line or a straight line is very simple, but it is actually the most fundamental and very challenging task to be solved. So we will see why just a linear function will be the interesting point, will be very powerful to solve many problems. And then it continued to develop to keep getting more and more algorithms for nonlinear, for mixed integer, discrete, especially global optimization and stochastic programming. Nowadays, even many of the problems still remain as unsolved research questions. So if you are interested to do more explorative or fundamental research, you will see many of the problems are still in need to be solved. You may be the contribution to add your name to the history if you get a super great algorithm. Okay, so next page is just a summary, different type of optimization problems. Within this course, of course, we cannot cover all the details. It's a huge, broad field, and many of the questions remain at the research stage. But you will have a look from optimization, how it's classified to deterministic. This is a fundamental one, like the basis to continuous, constrained, nonlinear, with all different constraints. This is the main line. And then we briefly talk about uncertainties, how to solve them with stochastic and robust. But this is not the focus of this class. This is more at advanced optimization course. Multi-objective is the same problem, more advanced level problem, but we want to give you a sense how to solve multi-objective because it's so important. Normally, you don't consider only one problem. You have economic environment, safety, all those objectives when you solve a real design or process operation problem. So this is important for chemical engineering. So we will go through the unconstrained first, which is simple is 1 to a constraint, and then some mixed integer problem. Okay, so many website has a lot of information, especially the one we provided in the lecture. If you want to explore more, you can have a look. This is not like the course that only constrains you to a certain chapter or both, but opens the door. You can see a lot of new concepts. You can use many of those methods in your individual projects, for example. And then the basic ones we show you, realize some of you, linear programming, think about some straight lines. But if you only got x1, x2, you can plot this in the 2D 2D plot, and it's straight lines, relatively simple. And nonlinear, it just replaces a straight line with some different functions, quadratic, exponential, all different nonlinear functions. But when we solve problems, normally it's not this simple 2D measure. We have x1, x2, x3 towards xn, and this n can be millions of variables. It will be a huge problem to solve that. Then when we start to think about those integer variables, either binary 1, 0 and 1, or the 0, 1, 2, 3, 4, 5. Those will be mixed integer programs, either linear or combined with nonlinear. So we'll talk about those problems in this class. And then the steps to solve optimization problem. This will be the logic flow when you want to use optimization to solve some real problems, or to do your design project, to do your individual project. So of course, we need to get a good understanding of the process first. The first step is to list all the variables and specific characteristics. If you still remember, we just talked about the variables are those things that can change while you're picking one that gives the optimal result. It gives you optimal objective function. So the second step is to determine the criteria for optimization and specify this objective function. You want to minimize your cost, or you want to maximize your utility, maximize your happiness. So those are all the objective functions. It can be a single objective or multi-objective you want to solve. Then the third one is to develop a valid process model relating the input-output variables using mathematical expressions. This is more like what you learned previously in modeling a process to add the equations with the constraints. So part 4 is if the problem too large, then you need to think about how to break it down to smaller parts or simplify the function or model. So some techniques such as linearization can be used. And step 5 is really to solve it, to apply a suitable optimization technique to the statement of the problem. Normally, when we solve it in real practice, the software will play a role. So in this course later, we will also introduce you different types of software you can use to solve those optimization problems. But also, it's the only opportunity for you in this class to get familiar with understand with the mathematics behind the computer programs. And last step is to check the results and do some sensitivity analysis. So it's commonly used, not just a single solution, but the decision makers would like to see what if I change one decision variable to upper 10%, lower 20%, what is the sensitivity of my results? So this part can also be done in your project. Okay, so that's a broad overview of what is and how to do, why we need to do optimization. Then for this class, we listed the aims and the objectives. You might have seen this on the website. So we will understand the opportunities for optimization, translate this qualitative description. Instead of the descriptive way, we want to use the mathematical modeling using the framework and formulate the mathematical problem for optimization to solve engineering applications, and also to implement and solve those problems using tools and software. This is very important for you to really use these tools to support your work. So some techniques of GAMS is a software for optimization. We will download this on computer, run some modeling and the solving. And MATLAB has optimization toolbox or different optimization solvers can also be used. Or the easiest way, Excel also has an optimization solver. We don't suggest you to use Excel directly, as this is more advanced in year 4 or graduate level. Excel can solve more basic problem, but the limitations are still there. If you want, you can easily learn some basic methods. But in this class, we won't focus too much on it. In this year, another session on Python will be introduced, because you have seen the emerging trend of machine learning, deep learning, and the best programming language now for machine learning is still Python. Therefore, we want to show you some more basic optimization code and the solvers implemented in Python to give you a sense. So if you have programming foundations before with Python or Java, those general programming language, you can use that to solve your project or learn more, but it's not a requirement for this class, but it will be very beneficial to your future study and career. So interpretation, explanation of the solution results obtained from the optimization model are very important. That differentiates you from just a computer scientist, a graduate from School of Computing. They can get high salary, but a student from chemical engineering, you can also see not only the computing techniques, optimization, machine learning, programming, you're able to do comparable to the students from computer science. But also you are able to interpret it, to use these tools to strengthen yourself. So that is what's the objective of learning this course. And then the final report and presentations. So based on this, we give you some logistics about this course. We will have lectures every Tuesday, 6 to 9 p.m. at your common 5,000 level class. But this year, as this first week, we use online learning. So that's how you are watching this video. But this Saturday, as I sent email earlier, I will hold office hours first in my office. I sent to you by email, 10 a.m. to 1 p.m. And later, also for the first 3 weeks, I want to really communicate more with you to see what you learn or what questions you have from this online teaching. So I will also use 2 to 4 or 5 p.m. in the room I sent to you, another classroom. I will be there to put the video there, and also I will be sitting there to answer any questions or communicate more with you about your expectations of learning. Okay, so as I said, it's a lot of explorative resources online. Understand for most of the undergraduate students, you might be quite busy with other courses. So I hope this one can be a very strong tool to support your engineering learning in school. So it's not a lot workload for this class, but if you want to learn more, it can be abundant resources for you to do explorative learning. But for graduate students in this module, I hope you can link what you learned in this class to your research topic as well. As optimization is really a universal tool, you can optimize all your process, all disciplines, all the experiments you're doing, or some interpretation you want to apply to your project. So this is a good opportunity. We can talk more if you think you can use certain optimization to your own project, to your own thesis. Okay, and for the evaluation criteria for this class, we don't have midterm or final exam this year, but only 2 quiz. So quiz will just be multi-choice questions based on the content we put in the class materials, in lectures. It's very basic test of optimization, basics, analytical skills, or basic numbers, very easy for computing, and critical thinking. So it will be open book, open notes, but no internet. And it's on computer, it's computer based, 30% for the 2 quiz. One planned in week 5, after week 5, one planned around week 9. So I will send you the detailed time when we start the semester. And the 30% is allocated to one individual project. So this is a bit open-ended because I don't want to constrain you to solve, or everyone solves the same problem that may not be interesting to you. So you can choose your topic. I will give you some options later. And then to apply what you learned in class to real practice. So this is a very interesting part as many students submitted very fun projects. You can be creative, or you can just fulfill the very straightforward requirements. The quality will be evaluated together. And then the 40% is for the final group project. We will have teams. After several weeks, you will have a team of 4 to 5 people, and then do this group project. This is given topic, and you will do it together. So we will announce more details, but don't worry. At the very beginning, I want to give you a sense what the workload is like for this course. If it doesn't match your expectation, you still get opportunity to drop it in week 1. So for individual projects, you can choose one task from the 3 categories. 3 different categories. You only need to choose one, which is most exciting or most favorable to your needs, if you can see. If you see the value, okay, so you can choose one task from the 3 categories. I will give more details later, but now have a look at the statement. The first one is review and reproduce the results of one scientific paper. This is a very research-based project, because many of you have some research experience already, so you read a lot of scientific papers. This one is like you to go through to read it, and then use what you learned in the class or the methodology provided in the paper to reproduce the results. So the paper not constrained to a certain small field, but generally relevant to optimization. Okay, and the second one is a bit more broad. It's raise one optimization related research question and answer it. So for this part, that gives you an opportunity to link this to your real needs. Like you can link this to your design project or to your experiment, to your even investment problem. So it's not limited to a certain field. And last one is more advanced. Write one complete optimization program, better to be realized as a software. So this will be very interesting. Last year, several students tried this one. So some designed a very nice user interface even to let the decision maker to design your household, your house, using the software to optimize the layout and maximize the space, for example. So those kind of the software type optimization will be very helpful and give very good value to that. But it is also advanced, so you can evaluate how much time you can invest. But the overall judgment will be based on the quality of the work. So it doesn't matter which one you choose, but you need to formulate the problem well in the way to as optimization, and then show the results validation. So this will be due after the recess week. We will release you a deadline to submit this. Okay, so if you read the details again, either summarize one scientific paper relevant to optimization. It's better to be applied in engineering, energy, and the environment. But if you got other domain paper, you can also discuss with me to see if it's good to use. So summarize and also reproduce. Remember, also reproduce here. Or raise one optimization relevant questions and answer that. Third one is to write a complete program as a software. So this is 3 categories you can do. We don't give you a specific topic you must, but if you want, I can show you some previous year students project later. Or if you don't have a clue how to proceed with this, talk to me or a TA to get a question to study on. So it's tons of good questions to do the individual project. Okay, and then for the final group project, it's mainly the second half of this course. When you have already learned the basics and the programs, we will give you a problem statement that will be very relevant to the real world practice. In week 3, we will have a guest lecture. So the guest lecture will talk about some real world practice about this group project topic as well. We would like you to form a group of 5 people. 4 is also acceptable. And then to work on this, we'll give you evaluation based on the understanding of the problem, the methodology, results, report, and the final presentation in the last week. Note that we will have team member evaluations, so teamwork is very important. we will have the team evaluation considered. Alright, so this is a tentative lecture schedule based on last year. So this is the first week since we are using the e-learning, so you can have the whole week at your flexible schedule to go through this lecture to get the overview and introduction. And then on Saturday, as I said, you can come to talk to me if you want to get a deeper understanding of the course and the requirements. And next week, we start to touch a real problem formulation. We start with the most fundamental unconstrained, which means no constraint, just objective. How do we solve such problem? And also if we have single variable optimization, how do we solve that? This is a very basic one. Because if it's multi-variable, you will have more complex formulation. If we have only one single variable, only one x, how do we formulate that? And then in week 3, we will have the guest lecture. We'll give you more information next week. And the TA will come to give you some introduction on the software. Week 4 is Chinese New Year, but we will take the course off and move the content to the next week to introduce the constraint multi-variable optimization with some case studies. So if you have time during holiday, you can try to practice these, and also convex optimization. So then we will move to the computer lab to have our quiz 1. It's either week 5 or week 6, depending on your learning progress, because we got a holiday off in week 4. And also the linear programming will be introduced with a core component before and after the recess week. And also the later part, we will study some mixed integer programming. Instead of the continuous one we studied in the first part, we'll have mixed integer introduced as well. And also the quiz 2 after mixed integer introduced. Then we'll give you more advanced level introduction on multi-objective optimization, stochastic programming, and machine learning basics, because machine learning needs optimization to fulfill its computing. We will show how those machine learning problems are formed and optimization is used. So this part is more advanced level. We won't have a quiz to test you, but you can use that in your project as well, or just for your own learning purpose and the future career utilization. And the final week, we'll have the group project presentation and give you the final evaluation. That makes the end of the course. And for textbooks, I will put reference textbooks because it's not really required step-by-step following textbooks. But these are very good learning reference. If you find some points you are unclear, you can always find the corresponding explanation in the book. We don't follow the exact chapters of the book, so it's still based on our slides on teaching materials, lecture notes. But the book will give you a more comprehensive, it has more content in the book. And another way is just search online resources. There are abundant optimization and computing resources online. So whenever you got a question, try to solve online to find it. So this book, authored by EFL, will be the main textbook, while the second book by Professor Euclides will be the good supplementary to read more about the methods and application in engineering. But I think this is an e-version, free ebook available, so you can download that from the library and search a book. It has very good examples inside. You can also choose some of the examples as your individual project. Okay. And software we introduce is an important component if you want to deliver the results. We like you to reproduce the optimization problem in individual project, or to solve your self-raised questions, or to develop these softwares. All will require your use of software. So the very basic level is Excel. So if you want to read, we won't teach this to you because it's very basic step by step. It's limited to certain type of problem. You can have a look, but it's not recommended in this class. We aim to show you more of the advanced level software like GAMS is the main tool we will use for this class. It's specifically designed for optimization, especially for large-scale problem formulation. So it's when we use it to solve a real-world or very complex research problem, we need to pay for servers. But for small-scale problem, it's all free. So for the class, you can just download this on your laptop or computer lab. We have downloaded already, and solving small-scale problems are totally free. But if it's beyond it, if it gives you error message to say it's beyond the problem scale for free solver, you can write your code, your model in GAMS, but go to this website, it's solvers to solve that. So GAMS is the tool to let you write your model. What is my objective function? What are my constraints? To write this problem formulation, and the NUS is a solver website. It's a mathematical steps. You don't need to input anything but upload your program, your formulation, your GAMS file, and get the solution. MATLAB is what you are familiar. I hope most of the class has learned MATLAB in your previous course or your own practice. I will do a survey later next week to get understand of your background. But MATLAB will assume you know the basic operations, and then there are many solvers. The CVX is good toolbox to solve convex programming, and they also have a MATLAB optimization toolbox. So we will show you the software is updating quite fast, so they have different toolbox to apply the state-of-art solver to solve all different kind of optimization problem. In the end, Python and the other programming languages also very good to use. I'll give you some examples later. And AIMS is also similar to GAMS, is an optimization platform. Alright, so that is the basics about the class. Okay, so here I want to show you one example done by the last year student project. A lot of students last year studied the NBA problem. So you might have been watching a lot the sports, basketball games, and you know that the NBA, they hired a lot of people to do the data analytics and optimization. So it's no longer the strategies by the coach itself. It has a strong technical support team, like based on the historical data, on the performance by each player, you can optimize the strategy. Although there are a lot of uncertainties, these strategies may guarantee you to obtain relatively better performance. So this example done by last year's student, very interesting. So the goal here, like it's very easy to understand. If you want to study a similar problem, try to get more innovative points here, but it's very good study, very good data for use as well. So he wants to maximize the total points by the team, so by all the games. So the summation of the points by the time played and the for each player. So they have different lineups. These are the historical data for different combination of your favorite players, and get the relatively the net points for each game, and then get net points for each minute. So this first data collection process will give you the parameters for this model, and then it will decide the total time, 48 minutes if it's given, then the minutes allocated for each of the lineup will be determined. So it's very interesting to help the coach to decide which lineup, which team of the team members to choose to form the best group. So this is a very basic problem formulation. You can make more analysis, but the student did a very good job in analyzing initial data from the base case scenario, and there are more analysis to solve this, and based on the result, further give suggestions and extend analysis. Sensitivity, uncertainties, predictions is all possible. Okay, so it's just one example to link your most interested field to the problem.